Okay, so we're going to go over that stuff in a minute, but solid, symbol. S, liquid, symbol. L, gas. Aqueous or solution of. AQ, so aqueous just means a solution of what? Or in what? Water. I would think agua, aqueous, same thing. Forms a precipitate or yields. Arrow, it's an arrow to the product side, right? Reaction is heated. Anybody? It's an arrow with a triangle. It's actually, yeah. So if you're trying to tell me something that's heated over a Bunsen burner, you draw an arrow and you put a triangle on top. You're changing the temperature is what that means, change. Requires a catalyst. You just draw an arrow and then you put the catalyst over the top. So the catalyst in this specific case was manganese dioxide, or manganese 4 oxide actually. And then precipitate, yeah. It's just writing down this, I kind of did it a little sloppily. It's writing down the arrow, and then whatever the catalyst is, you just put it above the arrow. So if the catalyst was hydrogen peroxide, you put hydrogen peroxide at top. So anytime you're putting something above the arrow, you're telling me that you're adding something to the reaction. So if it's heat, if it's a catalyst, whatever it is. Last one, precipitate. Any idea? I just told somebody. You can either say, right, you can either put a down arrow like this in parentheses, or PPT, which means precipitate. PPT is the short order of precipitate. So we're going to use that a lot when we write down our chemical equations. We're going to do all of these together here. Hopefully you've started them so that whenever I'm doing them, they're not new. This is just a quick review of some of the stuff we've already learned that we're going to be applying here. So basically today I'm going to show you how to write out chemical equations, and there's 5 different types. We're only going to do synthesis and decomposition today, and I've got some cool demos for you today, and then we'll do the other 2 later, and then we have 2 more labs this week. So this is a very lab-based unit where you actually see the chemical reactions and see the gas formation, see the precipitate formation, etc. So law of conservation of mass means what? I heard it. Matter, mass cannot be created or destroyed. So why would that apply to something like that we said earlier called a BCE? What did the B stand for? Balanced chemical equation means that how many carbons you have on the left, you're going to have the same number of carbons on the right. Same number of oxygens on the left and right. So you can't destroy matter or create it. You have the same on left and right. Indicators of chemical changes. I got the first one. Precipitate formation. What else? Heat. Okay, we'll say heat evolved. What else is telling you that there are chemical changes going on? Unexpected color change. What did you say, Audrey? Okay, so unexpected color change. Bubbles or gas evolution. That's a pretty good list. Good job. Okay. Or light, fire, phosphorescence or luminescence. Pure substance. Don't forget, pure substances are either elements, which you find on the periodic table, or compounds. Elements at room temperature, you say solid, liquid, or gas. And phases of matter, which one takes the shape of its container? A gas takes the shape of its container. Because if my liquid took the shape of my container, my liquid would look like that little green wiggle shape. But my liquid looks like this shape down here. So liquids don't take the shape of their container. So, gases definitely do. And then aqueous we just went through. Yay, okay. So this was all in anticipation that you'd already done that homework. But I didn't want to give it to you because you already had the other stuff to do this weekend. Reactants yield products, yes? Okay, don't need to go through any of this. No, atoms rearrange themselves. They're just going to be exchanging partners or moving to a new location in the same atom. So photosynthesis is, let me tell you my song. Ready? Okay, the sun does have a formula. Let's just say energy. Light. Okay, the sun and the rain and the CO2. Guess what? It's CO2, okay. Makes food. Formula? And oxygen for me and you. So carbon dioxide and water yields glucose and oxygen. So you like my song? I teach that in bio. I made people go and perform it around school. It was pretty awesome. Yes. So H recombines with C's and O's to make glucose and so on. So it's just a rearrangement of atoms. You could have remembered photosynthesis way easier if you had had that song. Okay, so this is the first equation. We're going to go through the first 5 right now. You know how to read chemical equations, yes? Or would they read the words and write a chemical equation? I'm waiting on some more masters, though. I only have 4 masters on my nomenclature master sheet, and I don't want to put that grade in. So I need to retake that nomenclature quiz as soon as possible. All right, so in solid zinc, what do you write for that? Being what? Solid is added to a solution of copper 2 sulfate. Formula? SO4, and you can put parentheses SO4 if you wish. It's okay if you don't, if you're getting the hang of the separation between the cation and the anion. It's aqueous, though. I'm sorry, no. It says a solution of. Solution of means aqueous, so AQ goes there. Okay, and then it doesn't tell me yields, but it's telling you those react, and then it tells you something else. So it kind of indicates to you that you're putting a yield symbol. And it's going to yield aqueous zinc sulfate. Go for it. Well, what's sulfate? So, hold on. What's zinc? What's zinc's charge? Zinc is a 2+. You have to know that. It does not tell you that because it only has 1 charge. So I don't put parentheses 2 because there's no question about what its charge is. It doesn't show up in that nice column up here. I'll table this. So zinc is a 2. Sulfate has a 2. So guess what happens whenever you put them together? They don't cancel. They reduce to 1. I like to correct people on that because they don't technically cancel. All right. So sulfate ends up being like that. It's aqueous as well, and it forms a precipitate of copper. How do you write that? Cu. And I could put PBT or I could put down arrow. I like to put down arrow because it's easier. I'm slightly lazy. Okay. Is this balanced? How many zincs on the left? 1 zinc. That imaginary coefficient in the front tells me 1. So there's 1 zinc over here. How many zincs over here? 1. And I'm going to put parentheses around that because this 4 does not apply to anything but what? Not sulfate. The oxygen within sulfate. So there's only 1 zinc. Okay, check. Good. Copper. There's 1 copper here. What's the coefficient after that one? I mean the subscript after that one. 1. Okay, so there's 1 copper here. So far, so good. And then since sulfate stays together, see how sulfate just gets a new partner? It doesn't actually change the way it looks. I like to think of sulfate as sulfate still, not 1 S and 4 oxygens. Because that's when people get mixed up. So how many sulfates are over here? 1. So 1 contributes to the first element and the second ion here. So 1 sulfate here, how many sulfates here? 1. So that's how you're checking your balance. I like to just start from the front and check, and then check, and then check. So that's a 1, 1, 1, 1 coefficient ratio all the way through. We are balanced and good. Done. Okay, when solid magnesium chloride is heated. Okay, solid magnesium chloride, go. Mg parentheses Cl O3 parentheses 2. Okay. Solid, thank you. It's heated. Arrow triangle. Okay. And solid magnesium chloride forms. Go for it. How do you get MgCl2? Where does that 2 come from? Charge of magnesium, chlorine gets a 1 minus crisscross. That 2 comes down low. Solid plus YO2. Oxygen gas is, I just heard it, I thought. What's the word that tells me I have 2 of it? Diatomic. Okay, so what I'm trying to show you is that you don't write just O. If I just wrote O, I would count that product wrong. So if it's all by its lonesome, not combined with anything, you have to write it diatomically with a 2 on it and then tell me it's gas. All right, so start from the top. Let's balance this. How many magnesiums? 1. There's a 1 in front of here, so I'm going to look over here. How many magnesiums? 1, and that's because of the subscript behind it. That's an imaginary 1. 1, 1, we're good. All right, how many chlorines? Why 2? Because the 2 contributes or distributes in to everything within. And the reason I'm counting the chlorate individually here now is because this broke up, so I can't look for chlorate over there. I got to just double check each element involved. So I've got 2 chlorines here. How many chlorines here? 2. Okay, perfect. How many oxygens here? 6. 2 times 3 means I have 6 total oxygens. How many oxygens over here? So what do I need in the front? A 3 coefficient. Okay. So you've seen the blue. I never changed the blue. I never changed my chemical reaction. I've never changed the subscripts. I don't change a darn thing. The only thing after I go ahead and write the equation out, the only thing I can do is add big number coefficients, and that's it. So never, ever, ever change anything after this. Who's already learned this stuff before? Somewhat. Okay, awesome. About half of this. I'm going to go through a couple more examples. Okay, solid sulfur reacts with oxygen gas. So solid sulfur, S. Where did we get a 2 from? It's not diatomic. Remember the big 7? The big 7 in hydrogen, the big 7 is N2, O2, F2, and down. Sulfur is not in that 7. If not, it'd be kind of like a tumor on the 7 or something. So hydrogen's over here. Okay, so sulfur is just sulfur. And I'm going to write it S with the solid here, and then I'm going to show you another way to write it in just a second. All right, reacts with oxygen, so plus O2, gas, right? To form gaseous sulfur trioxide. SO3. Gas. Okay, so see how reading this now, we are using nomenclature like it's nobody's business. So you really got to be able to pull back those those polyatomic ions so that you remember where things fill in. All right, how many sulfurs? 1. 1, awesome. 2, 3. Okay, I can't put anything in front of this one without changing that one. So I have to change these as a pair, yeah? What do you want to put here? A 3. So notice if I have 3 here and a 2 here, if I multiply by their opposite numbers, it's going to fix itself, right? What's that, like law of multiples or something like that? So 3 times 2 is 6, and if I put a 2 in the front of here, I have 6 O's now. But what did I just change? Sulfur. I have 2 S's, so I need 2 S's. So it's a domino effect. After you change one, go double check that you didn't change something else by accident. It's not like, it's a 2-second process. All right, we're golden. We're good. Okay, can't scroll down. Solutions of silver nitrate and sodium bromide. You've got this in front of you, so I'm going to write right here. Silver nitrate, go for it. Right, AgNO3, and it's a solution, so it's aqueous. And sodium bromide. NaBr. That's because Na had a 1 plus, Br had a 1 minus, crisscross, 1, 1. Looks like there's nothing there. Solution, aqueous. React to form aqueous sodium nitrate. NO3. So if you got the nitrate in the beginning, all you're doing is putting it with a different partner. Originally it was with silver, now it's with sodium. And it's forming an aqueous solution, so that's AQ, plus a precipitate of silver bromide. AgBr, precipitate. I'm drawing an arrow down there. All right, do you see any subscripts here? Subscripts. You see the nitrate, right? That's it? So, did nitrate stay nitrate from top to bottom, from beginning to end? Yeah, so this nitrate hangs out, the N hangs out with the 3 O's the whole time. So if I don't see any other script, I'm trying to say substrate and the other one at the same time. So if you see the nitrate's not changing, then you're good. Then double check. Silver's 1. Silver's 1. Bromine's 1. Bromine's 1. Sodium 1. Sodium 1. We're good. We're awesome. All right, what kind of reaction is that? Single replacement, double replacement, combustion. Which one? Do you see how silver lost its girlfriend and sodium picked her up? Double replacement. Only thing that happened was silver and sodium switched. So they're doubly replacing it. That's what's going on. So we're going to go through this some more in detail. But I'm going to stop here. Hold on to that paper. You've got 5 more. That's for homework tonight. It says finish lecture props. So you're going to do these plus a couple more. All right. And we're off. We were down some. We're awesome. Okay. So like I just said, we're going to do synthesis and decomposition now. These are the harder ones to remember because it's not like logic saying, what does the word synthesis even mean? Huh? Synthetic means fake, but synthetic comes from the word synthesis. So we humans make things synthetically. Think of the word photosynthesis. What does photosynthesis mean? Create energy from from the light, right? From sunlight. So we're making something from light. So photo means light. Synthesis means creation, to make. So synthesis here means we're making a compound. CMPD is compound from two elements. E is elements. So we have to take two things in their elemental forms, smush them together. If they are ions, we will crisscross. We're going to get to that in a second. Decomposition, what do you think that means? To break down. So pretty much the opposite of synthesis. So we're going to be breaking it down up here. And that's actually going to usually break it into two elements as well. So we're going to talk about those two today, and then these other ones we'll get into a lot more detail in the rest of this week. Deal? Thank you. And then we'll have some time at the end of class to work on homework. I'll show you my demo, my favorite demo. And we're going to do a lot more information on all of these. So I'm going to the next slide because you're going to see synthesis and decomp, and then on the next two slides. The rest of those will be for tomorrow. All right, so synthesis. Just told you, smushing two elements together. However, if you have ions, or if you have a metal and a non-metal being smushed together, you must crisscross charges. CCC means crisscross charges. Do not forget that when you're making ionic compounds, you still got to go and find out what element or what ion with this one, what ion with this one. And then I got to crisscross those charges. So we're using nomenclature stuff again, as promised. And the two main types here are the kind of the general formula is when you're just you're pulling A and B together to make AB. For the first one, it's called binary because you have two elements together making a binary ionic compound, a BI. Remember, BI compound. And so, Brendan, give me an example of a metal. What's your favorite metal? Okay, zinc. I heard you. Okay, so let's say zinc. Audrey, give me an example of a non-metal. Fluorine. Okay, how does fluorine get written when it's by itself? F. Why? Anybody? It's in the big seven, right? All right, so we've got solid metals. Metals are always solid at room temperature. We've got a gaseous non-metal because they're usually gases at room temperature. When they come together, you have to crisscross their charges. So in your head, you're saying, oh, Miss Ella, I know the charge of zinc. What is it? 2. You just have to memorize that one, okay? So zinc is a 2. Fluorine is it's in the 7th group, but how many electrons does it have to gain to be noble? 1. So it gets a 1 minus charge. That's how we're getting these charges. You're seeing how far away they are from noble gas electron configuration. So all I'm doing is in my head switching those to say Zn F2. Is that balanced? Look at it. It sure is. That 2 and that 2 are the only thing that I'm really looking for. And this is solid because ionics are solid at room temperature. All right, so that's the first easy one. You just got to know how to find your charges in the PTOE. Second one is where you have a metal oxide. So give me a metal, Jacob. Oh, gold. Okay, I'll try it. Oh, let's say gold normally has a 3+ charge. I think that's right. So gold oxide. So give me the formula for gold oxide. If gold has a 3+ charge. Anybody? 2O3. Where am I getting this 2 from? From oxygen. You're crisscrossing in your head this 2 down and this 3, because I just told you gold had a 3 charge. So gold oxide plus water is going to yield a metal hydroxide. OH, remember hydroxide? Yeah, this one? All right, so when I put this together, AU goes in the front, hydroxide goes in the back. What am I missing? The subscripts. Okay, hydroxide has a 1 minus charge, so that stays a 1. We're good. But what did I just tell you gold formed? 3. So that's going to be gold 3 hydroxide or just gold hydroxide. Okay, is this balanced? It doesn't look like it. Let's go double check. I see I have 2 golds here. I only have 1 here. So what do I need? A 2 where? Coefficient, right. So now I have 2 times this 3 to show me everything within this parentheses. So how many oxygens over here? 6 O's. How many hydrogens? 6 hydrogens. So all I did was say 3 times 1, 3 times 1. So there's 3 of both those, but I have 2 overall, so I got to double it. So 6 and 6. All right, how many oxygens over here? 4. How many hydrogens? 2. Let's fix the 2 one first, because see, I have oxygen in 2 places. That's hard to balance. So let's go with the easy one first. Let's balance the H's first. So if I put a 3 here, I now have 6 H's. Did that fix my other problem? Yeah, because I have 3 and 3, which is 3 plus 3 is 6. Now I have 6 oxygens and 6 hydrogens, yeah. Okie dokie. This one's a little harder to remember. Metal oxides plus water yields metal hydroxides. All right, so let's go through these. Hydrogen plus chlorine. Write these down with me. I'll just choose a couple to do, okay? Hydrogen, go for it. Loud and proud. H2 plus Cl Y2. Because it's part of the big 7 hydrogen, right? Always remember your diatomics. What do they yield when you put them together? HCl. Where did the H come from? It had a 1 plus. Cl had a 1 minus, because it's in the 7th group. It's 1 away from noble gases. So that's how I got these subscripts. Well, how do I balance it? The 2 coefficients, because I have 2 of each of these. I need a 2 up here now. All right, the next one, magnesium plus oxygen. Mg plus O2 yields MgO. Why MgO? Where are the subscripts at? What was it before when you were crisscrossing in your head? And O2, right. So those 2's and 2's came down to form Mg2O2, but we all know you can't leave it like that. You have to reduce it down to 1's and 1's. Is that balanced? No. What do you want to do? 2 in front of here, and then 2 in front of the Mg. Because I already had 2 O's, so I had to put a 2 in front. Well, then that screwed up my magnesium, so I had to go back and fix the magnesiums. Let's do one more. Let's do barium plus water. I'm sorry, barium oxide plus water. BaO. Huh? Where'd the 2 go? They both have a 2. Barium is a 2 plus, oxygen has a 2 minus. So Ba 2 plus. If you better write this down in your paper someplace, who cares? Get good at it so you can do it in your head so you don't have to waste your time. But I do that sometimes when I'm still trying to figure out what my charges are. All right, plus water. What's the rule here? You just wrote this down. Metal what? Hydroxide. Who's my only metal here? Barium. So it has to be barium. And then barium hydroxide is what? OH, but parentheses. Where'd the 2 come from? Barium's charge. You always have to, so like I just crisscross charges over here, and then when I make my new compound, I'm still re-crisscrossing charges every single time I form these compounds. All right, so balancing, I have, oh yeah, I do. 2, 2, 2, 2, 1, 1. Awesome. Because we have 2 hydroxides, so that satisfies my 2 O's and my 2 H's. All right, let's do, I'm going to come back to this one. Decomposition. Decomposition has a couple of more possible reactions than synthesis does. I'm going to give you a minute to write down those, because this is the hardest one to remember. And you do have to remember how these break apart, unfortunately. Smart. Alright, start from the top. I'll go kind of slow. You're still catching up, but we'll get down there in just a second. Alright, so decomposition, it doesn't just happen naturally. So what do you think water decomposes into? What's it made of? Okay, so what do you think it breaks down into? Hydrogen. Well, how does hydrogen exist in nature? H2 and then O as O2. So my water is still water. It's still H2O. If it was breaking down into the two elements that makes it up, it would be making H2 and O2. Well, they're both flammable. Do you think I'm drinking a flammable liquid? No. So it doesn't just naturally happen all by itself. You got to kind of just push it a little bit. How do you push it? You give it energy. Okay, so you always have to add energy to these types of reactions. That's why I put a big triangle, because what's a triangle mean? In this case, heat change. So I'm adding some heat to it. Another way you can do this is by adding electricity. Elect is kind of the way you write electricity. You can put a lightning bolt or something like that. You can add a catalyst. A catalyst, its job is to speed up chemical reaction. That's probably about it. So you've got to help it out to get started. So the first one is just the opposite of synthesis. We take the compound, we break it into the two elements. So let's do sodium chloride. How does sodium chloride break down? Into what? Almost. Cl what? Why Cl2? Diatomic. Don't forget that you have to make sure you write into two of your diatomics. Balance? 2 up here, and then 2 there. Okay, and so I'm not writing my states all the time. If you need to write your states all the time to help you, totally do it. You won't have to do it like every time though. All right, metal carbonates. What's the formula for carbonate? 2 minus. Okay, let's do sodium carbonate. Formula, sodium carbonate. And they what? 2 CO3. So Na2, that 2 came from carbonate, yes? I will put that parentheses there to help you see carbonate's still there. All right, it decomposes under heat to form metal oxide. What's the metal here? Na. So sodium oxide, go for it. Where'd the 2 come from? Oxygen. See how you're crisscrossing in your head? You gotta make sure you don't just like say the letters. Think about the numbers associated as well. So Na2O, because it's sodium oxide, the 2 comes from oxygen, plus carbon dioxide. Carbon dioxide is just our gas that's being released. So this is a ionic or covalent substance? Ionic. So this is probably a solid at room temperature. This one's a gas because carbon dioxide is a gas at room temperature. How many sodiums over there? How many over here? Awesome. How many oxygens here? 3. How many here? 3. 1, 2, 3. It's split, but they're all there. How many carbons? 1. How many carbons? 1. Check. It's a BC. It's balanced. Hi. Ooh, this one? Okay, awesome. Thank you. Last 2 examples. Metal hydroxide. So give me another metal. Potassium. We haven't used potassium yet. Okay. Potassium hydroxide. Go for it. Okay. What? dioxide is a 1- charge, right? All right, yields potassium oxide. K2O, thank you. The 2 comes from oxygen yet again, and H2O. So these are really, really similar. How do you tell the difference between them? The first one has a carbonate in it, which makes carbon dioxide. The second one has a hydroxy something in it, which makes water, which is, you gotta just see that hydrogen is gonna be creating the water part. Okay, so don't get these two mixed up, because what a lot of people do is they're like, oh yeah, it's carbon dioxide, and they throw carbon dioxide right here. And I go, where'd you get carbon from? If there's no carbon, you can't put a carbon over here if there was never a carbon to begin with, right? So don't make that little silly mistake. Is it balanced? No. What do I need to do? So if I put a 2 up here, because I have a 2 here, that gives me 2 Ks. That also gives me 2 Os. Do I have 2 Os? Yep, here and here. And then 2 H's. 2 H's. Yay. Okay, last one is the chlorate. Chlorate is ClO3, 1-, right? Okay, so let's do aluminum chlorate. Aluminum chlorate, sorry. Go for it. 3, where did the 3 come from? Aluminum's charge. Yields a metal chloride, which is what? Al. Where did the 3 come from? Charge from aluminum again. I'm crisscrossing. Every single time I have a metal, I'm probably doing ionics, yeah. Oh, on this one, it says metal, and so I have to determine, see, these examples are generic form equations. The M doesn't actually stand for a darn thing. It just stands for metal. So I'm choosing a new metal every single time. Yeah, that's what, well, I mean, I'm going to give you, these are generic formulas. I can give you any metal in the world and put it as a metal, as a, let's say, titanium hydroxide, or iron carbonate, or mercury chlorate. I'm telling you how to do the formulas based on these generic formulas. So I'm choosing aluminum in this case for what M stands for. So then in this M, I'm saying aluminum chloride from the MCl here. That M is a fake metal. You get to choose on this case, yeah.
H2O, is that H coefficient? Oh.
I'm sorry, my subscripts don't look like subscripts. That H2O. I'm just writing fast, sorry. Okay, so then aluminum chlorate, or chloride, plus O2. How do I balance this one? You guys focus. Okay, so I see I have a 3 here and a 3 here. Well, how many oxygens total over here? How many? 9. This is a multiplication. 3 times 3, no pluses here. So 9 O's over here. How many over here? 2. Okay, so how do I get 9 and 2? No half coefficients. Okay, so how about I double this one first? If I double this as a whole, then 9 times 2 is 18. Okay, so 18 O's over here, 9 here. Okay, now I have 2 aluminums over here, put a 2 here. How many chlorines here? 3. Why 6? Yes, this 3 distributes here and here. So that means I have 3 chlorines from the 3 out here, but then 2 times that number. So 2 coefficient times the 2 or the 3 here gives me 6 chlorines overall. So I have 6 chlorines here, 6 chlorines there. We're good. Yay! I tend to write that in your papers because this is a hard one. You guys made up aluminum, right? I didn't make that up. Let's do a couple more examples. Those are the only 4 types of decomps you'll do. That's it. You have to know though how chlorates decompose, how carbonates decompose, how hydroxides decompose. Yeah. Can you hold on 1 second? Okay. All right. So go ahead and do these. And right above the arrow, and I neglected to do that. All right, right above the arrow, something to show me that you're forcing it to occur. Huh? Catalyst, electricity, or your karate skills. Hold on. Okay, sodium carbonate we should have at least the formula for. What'd you get? I know, I just realized that. Yields 2 Na what? 2O. So this was carbonate. A metal carbonate always yields metal oxides and carbon dioxide. Yeah. It's just because we had already done it. And so I just was going, oh, I don't know where that 2 came from actually. My bad. That's the 2. 2s and 2s and 2s everywhere. Okay, so carbonates yield oxides, metal oxides, and carbon dioxide. Is that balanced all the way? Yep. So I'm gonna do electricity here. Lightning bolt. Harry Potter. Okay. Potassium chlorate. Yeah. Because it's not diatomic when it's combined with something else. It's only diatomic when it's all by its lonesome. If you just write O by itself, that's wrong. You have to write it like this. But when it's with within a compound, in your head you're saying, okay, this sodium forms this ion, this oxygen forms this ion, crisscross. So when it's forming an ionic compound, you have to choose its ionic charge, not its diatomic form. Cool? Okay. Potassium chlorate, go for it. Don't do the coefficients yet. Start me off first. KClO3 yields. So what's the generic formula first? So metal chlorates form blank and blank. Metal chlor, ice, and oxygen. Okay, so metal chloride here is what? Why no coefficients? I mean, why no subscripts? With ones, 1 plus and 1 minus, and O2 because it's diatomic. Balance? Okay, fix it for me. Okay, so why am I putting a 2 over there first? What are you noticing? Tell me your thought process.
3 oxygens and 2 oxygens.
So I see a 3 and a 2, so I need to fix them, right?
Just switch them.
So switch. So if I need 6, well, if I think about it, it's like what is it? Least common multiple. So the 3 and the 2 need to be just coefficients now. So the 2 goes here to say 3 times 2, which is 6 O's. 3 here to give me 6 O's now. How many K's do I have? 2. How many over here do I need?
2.
And then how many chlorines do I have? 2, 2. Yay. Water decomposition is what? You just told me. Oh, well. Got it. Note to self. No. This is why you don't read. This is my secret. Okay. And I'm going to hold off on this one. I'm going to show you something really cool first, and then we'll come back and do some more practice, and then you'll do your homework. Cool? All right. H2O yields H2 plus O2, and it's a coefficient of what are the coefficient? 2 here and 2 here. And I'm going to put catalyst. Cat. Not cat like cat, but catalyst like cat. Okay. So what